Okay, so what I'm going to do today is basically show you guys how to prove that a parallelogram has opposite sides that are congruent. So take a look. Okay, so in order to prove that all parallelograms have two pairs of opposite sides congruent, basically all we have to do is prove that one arbitrary parallelogram does. So the way I like to begin a proof is just by writing the word proof, and then we're going to make an assumption. So we're just going to let figure ABCD be a parallelogram. And once you've allowed a figure to be a parallelogram, well, you can draw it exactly like it is envisioned in your mind. Okay, so mine's not going to be perfect, but I am going to label this exactly this. Let ABCD be a parallelogram. So we are going to assume that we have a parallelogram. But if you have a parallelogram, well, that is going to automatically tell us by definition that side AB is parallel to side CD. So you're going to write that statement and you say AB is parallel to CD by the definition of parallelogram. And you might say, well, why didn't I use the other side? I just chose AB and CD just on a whim. You could have chosen the other one. So what I'm going to do from there is draw a diagonal. And there's no real need to mention this diagonal in the proof as long as you're drawing your own figure. And labeling this figure will be able to follow. So what I would do next is I would label this angle with a 1 and this angle with a 2, and the reason that I'm going to do that is because there are alternate interior angles there that are congruent. Angle 1 and angle 2 then are going to be congruent. So let's go back and write that angle 1 is congruent to angle 2 by the alternate interior angles theorem. And there you have it. So now that we have this angle congruent to angle 1 congruent to angle 2, you can make the mark. Alright, there's another mark that we can also make, and it deals with segment BD. Segment BD is congruent to segment BD. Segment BD is congruent to segment BD by the reflexive property. Reflexive property of, you might see the word congruence here. You might see the words congruent segments. In any case, and you might even just see the word reflexive property. But let's go ahead and write reflexive property of congruent segments. Now, if you were bothered by the fact that I never did use the other side, well, we're going to get to that now. So I would like to also say that segment BC is parallel to segment AD. So we can do that. We can do that in the next line. So BC is parallel to segment AD, and that is by the definition of parallelogram. And then, after writing the definition of parallelogram, we can mark a couple of angles. Let's just call them angle 3 and angle 4. and we can say that they are congruent. So angle 3 is congruent to angle 4 by the alternate interior angles theorem. So give me just a minute to write that alternate interior angles theorem. And a lot of you guys will use shorthand for that, and that's okay. And now what you'll see is that there are actually two congruent triangles. So from there, we're going to switch colors real quick. And now I'm going to say that the two triangles are congruent, and I have plenty of reason to do this. So let me show you why I'm actually doing this. So triangle ABD, be careful of the order. And once I say angle A and then BD, I have to go to the one with the open angle, the one that does not have a mark on it. So I'll go C, and since I went A, B, the B has one mark, so C, D, B. So triangle C, D, B, and those two triangles are congruent by the angle side angle, and I believe that's a theorem by angle side angle. Let's just say angle side angle congruence. And from there, it might be a postulate actually, but from there, what we can do is, since you know that the two triangles are congruent, you can actually come up to your figure and start making marks. So that would imply that AB is congruent to CD, and it also implies that BC is congruent to AD. And not only that, it would imply as well that angle A is congruent to angle C. So we have 6 corresponding parts that are congruent, but this proof is not really just asking for all 6 parts, it is only asking about opposite sides being congruent. So as our final statement, all we have to do is say that segment AB is congruent to segment CD, and segment AD is congruent to segment BC, and we're going to say by CPCTC. And if you've never heard these words, go back and watch a video about corresponding part. This means that corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. So I'm not saying, I don't need to mention all 6 pieces, but if I'm using any piece and saying that it's congruent after the triangles are already proven congruent, then you're using CPCTC. So you're actually finished with the proof there.